Hey guys, welcome. This is our practice test. We're going to go through it right now, so follow along if you like. An adult female panda weighs 200 pounds. Its newborn baby weighs only a quarter pound. That's not a quarter pound of the adult, but just a quarter pound, so it's really tiny. What's the ratio of the weight of the adult to the weight of the baby? So we're going from the adult to the baby, so A over B, adult to baby. Well, the adult weighs 200 pounds, and the baby only weighs a quarter of a pound. We can't leave a ratio. It's just asking me for the ratio. This isn't a proportion. I can't leave a ratio with a fraction. So I'm going to have to go ahead and figure out what could I do to make this a whole number. So I have a quarter. What can I multiply to a quarter to make it a whole number? Well, that'd be 4. Think about it. 4 quarters makes $1. So I multiply top and bottom by 4. That keeps my ratio equivalent. And my ratio is going to be 800 to 1. Okay, so that's quite a big difference. Might seem a little shocking, but yeah, a quarter pound baby, that's really tiny. Number 2, animal shelter has 104 cats and dogs. The ratio of cats to dogs is 5 to 3. How many cats are in the shelter? Now we know how many cats and dogs there are. That's the total, and it's made up of cats and dogs. And so we're going to write the equation like this. 5x plus 3x, so the amount of cats plus the amount of dogs should equal 104. I don't know how many there are, but I know their ratio has to stay consistent to 5 to 3. That's why I can use x. Okay, so that becomes 8x equals 104. Divide by 8. And when I divide by 8, I get 13 for x. And then how many cats are there? The first number goes with cats, so that's 5 times 13. And that's going to be 65. So we have 65 cats. All right, number 3, sides of the triangle are an extended ratio of 3 to 4. If the length of the shortest side is 6, what's the length of the longest? So it's kind of like the one up here. We know the sides, right? They add up, but they add up to the perimeter. I don't know what the perimeter is, but I know the shortest side is 6. So I'm going to take the shortest piece, which is 2x, and set it equal to 6. Divide by 2, x is going to equal 3. Now, what's the longest side? Well, 4 is the longest, so I'm going to do 4x, which would be 4 times 3, which is 12 centimeters. And that is our longest side. These are some basic proportions. We're going to do 4x equals 12 times 7, which is 84. Divide by 4, and x equals 21. 10 times 7 is 70 equals 20x. Divide by 20, and we get x equals 3.5. Over here, as soon as I see a binomial, I'm going to put parentheses around it. We're going to cross multiply. We get 7x. This is going to be 5x plus 25. Subtract the x, 5x over. We get 2x equals 25. And then divide 25 by 2, and we're going to get x equals 12.5. Are the polygons similar? If they are, write a similarity statement, give the scale factor. If not, explain. Okay, we know the angles are all good, so the angles are all congruent, so we're good there. Now we need to check sides. So 10 to 5, so I'm going to just check the sides over here. 10 over 5, we have 6 over 3, we have 8 over 4, and we have 14 over 7. Well, if you actually look at all those, these all reduce to 2 over 1. So yeah, all the sides are proportional, so we know that this is a similar polygon. So I'm going to say KLMN is similar to QRST. And our scale factor is 2 to 1. You could have got a scale factor of 1 to 2, depending upon which shape you went from. Okay. Number 8, the map is 1 inch is equivalent to 25 miles. On the map, the distance between two cities is 5.25 inches. What is the actual distance? We can set up a proportion here. We say 1 inch to 25 miles equals 5.25 inches to x miles. Basically, you're just multiplying here. So your value for x is going to be equal, 1x is going to be equal to 25 times 5.25. which is going to give you 131.25 miles. So just a basic cross multiplication problem. All right. Number 9. What is the value of x? Now we know that these sides, or these two shapes, are similar given to us in the statement. BC is going to match up with KL, so I'm going to do x over 5, and then we're going to do 18 over 12. Notice I went from this shape to this shape both times. I stayed consistent, cross multiply, get 12x equals 90, and then divide, and x is going to equal 7.5. Okay, determine if the triangles are similar. If so, write the similarity statement. Name the postulated theorem you use. If not, explain. Okay, first off, I have no angles, so I'm going to have to use side, side, side if possible. And we're going to take the smallest side here, which is 9 over 15. And then I'm going to take the next smallest side, 12 over 20. And the next side is 15 over 25. Okay, 9 over 15 will reduce to 3/5. 12 over 20 reduces to 3/5. And 15 over 25 also will reduce to 3/5. So these triangles are similar, and it is going to be by side, side, side. So we're going to write the triangle similarity statement over here. Actually, I'm going to write it on a separate sheet of paper just because we're probably kind of running out of space a little bit. So we'll just write it here. So triangle, the first triangle you can name anything you want. LSQ is similar to triangle. Now notice L is between the two larger sides, so it's going to match up with T. S is between the two smaller sides, it's going to match up with N. And then you have R left over, and this is going to be by side, side, side. Okay? Number 10. All right, let's look at number 11. We have the 90 degree and the 64. So I want to find this third angle, so I'm going to do 90 plus 64, and that's going to give me 154. And then I'm going to subtract that from 180. And so I get 26 left over. So yes, these triangles are congruent, similar. I have room over here, so I'll just do it over here. MBD is similar to triangle. Okay, so 26 is the F, B is the 90, and D is the 64. And this is going to be by angle-angle similarity. Okay. Alright, so far 2 triangles that work, and let's move on. Okay, I have 9 and 15, 10 and 6. I need to do the small with the small, so I'm going to start with 6 over 9 and 10 over 15. 6 over 9 is going to reduce to 2/3. 10 over 15, it's also going to reduce to 2/3. And then we have a vertical angle. So these are going to be congruent as well, and this will be by side, side, side. Or sorry, side, angle, side. So let's write this one in. Triangle NKR is similar to triangle. Again, the first one doesn't matter how you set it up. I started with N, which had the short side, so we'll go GPR, and this is by side, angle, side similarity. Okay. Our last one over here, these are 2 isosceles triangles, which means I should find all the angles. 71 degrees, those are congruent because base angles are congruent. If I had 71 plus 71, I get 142, subtract from 180, and I'm going to get 38 here. They're not congruent angles, so we just say not similar. A person 2 meters tall casts a shadow 5 meters long. At the same time, a building casts a shadow 24. How tall is the building? Okay, so we have, we could do height, and we could do shadow. So the person is a 2 by 5, and the building is x by 24. I don't know the height of the building, but I know the shadow length. I know the height of the human, and I know the shadow. We're all in the same unit, so we're all good. So 5x equals 48. 48 divided by 5 is going to give us x is 9.6 meters. Okay. Number 15 is going to use this picture here. DE over DE is going to be equal to AB over AB. That one is kind of a silly one. EF to DE is AB. It's going to be what matches with EF, which is BC. Okay, find the value of x. We're just going to do the simple 36 over 20 equals x over 15. We're going to cross multiply, and we're going to get 540 divided by 20, and we're going to get x equals 27. Over here we can do 5 over 4 equals 8 over x. And again, there's more than one way you could do these, so a lot of times you might have a different setup than me, but we should come up with the same answer of x equals 6.4. Oops, sorry, that was off the screen. There you go. Sometimes always never questions are always good. Two equilateral triangles are always similar. That is going to be always true because they'll have 60, 60, 60, so always. Angle bisector triangle divides a triangle to similar triangles. Yes, angle bisector always does that. Rectangle is similar to a rhombus. Sometimes. The rectangle always has 90 degrees and rhombus doesn't. So that'd be a sometimes. A student says since all isosceles right triangles are similar, all isosceles triangles that are similar must be right triangles. This is incorrect. I'll give you a quick example. You could have 40 degrees and 40 degrees. Okay, those would be the same. And these would be isosceles. So these two would have to be 70 and 70. These two triangles are similar, but they are not right triangles. All right, thanks guys. I'll see you on the flip.